Okay, so what I was saying for this one is you want to find x, which is right here. So what you're going to need to do is add, Lord, there we go. You're going to need to add 112 and 151 and subtract it from 360. 360 minus 112 plus 151. Like that. And what you end up with x is, well, let's see, you should end up with, I believe, 97. All right, and for number 15, look at what you're given first. So this is 74, and I'm trying to figure out this arc, or this angle here. So if I know this is 74 and I know this is the diameter, right, then I know this is 180 minus 74. So this is 106. Now I want the degrees here, so this is going to be 1/2 of 106, and you should end up with 53 degrees. 16 is pretty straightforward. And number 17, again, is a shape. So you just got to look at what information you need. So you need this right here, right? So you know it's not 70 and 84, so you're going to take the whole circle, which is 360, and subtract 84 plus 70. And so the arc is 206. This whole arc here is 206 degrees. So if you're looking for the angle here, you're going to take 1/2 of 206. And you should end up with x equaling 103 degrees. Now you should be able to do inscribed circles. So we've talked about central angle is equal to the arc. The inscribed angle is equal to 1/2 the arc. All right, now we're going to talk about all the other kinds of angles that are formed in circles. So another type of angle are angles formed outside the circle. This is what I was looking for. So there are 3 other types of angles formed within a circle. And so one you've got from a tangent and a chord. And what you'll notice is that you take the arc and divide it by 2, and once again you'll get the angle. So this is very similar to an inscribed angle. You use the same formula. So you've got this arc here, which is 148. And so if you want an angle measure, it would be 1/2 of 148, which is 74 degrees. So again, if you take 74 degrees and multiply it by 2, you'll end up with the arc length back at 148 degrees. So this is going to help you with numbers 19 through 22. So let's go ahead and do some problems. Let's look at number 19, which is on page 9. Here's number 19. So again, if we know the angle measure is 65, well then the arc length here is going to be 65 times 2. And 65 times 2 is 130. But actually what we're looking for is this part here. So it's just a matter of taking 360 minus 130, which leaves you with 230 degrees. All right, so again, the formula we're using is 1/2 the arc. So here we go. I want to know this angle here. I know this is 84, so the arc is going to be 84 times 2, and that is 168. And now I want the other half of the circle, so it's going to be 360 minus 168, because my whole is the whole circle, and that gives me 192 degrees. So x is 192. Well, down here is a little bit challenging. We know this is 220, so to find this, we would do 360 minus 220 first, right? So that's 140. And then you're going to take 140 and divide it by 2 or times it by 1/2, which gives you 70 degrees. So this angle here is 70 degrees. It's just using the information a little bit differently than what you already knew. All right. Now, starting with number 23, we've got a new type of problem. So let's go back to our notes here. These problems all look like a crisscross in the middle of the circle. And this is an angle formed by two intersecting chords. Remember, chords being lines that have two endpoints on the circle. This has got an interesting formula. Basically, to solve for x, to solve for the intercepting, you're going to take the sum of the two intercepted arcs. So this would be one of your intercepted arcs, and this would be the other, and you take half of it. So x is going to equal 32 plus 54 divided by 2. And that's just a fancy way of writing this formula. Instead of writing 1/2, you can take this and divide it by 2. Okay, so literally you take 32 plus 54, which is 86. 86 divided by 2 is 43. So this angle here is 43 degrees. If you wanted to find one of the arc lengths, then you can just rearrange this formula. So let's say you wanted to find the arc of AD. Okay? So if you wanted to find AD, right, what you could do is take the measure of the angle times 2 and then subtract the other arc. So I'll show you what that looks like when we're looking at it in the problem. All right, so now we're going to look at number 23. Which is here. So this is what I'm talking about. We're looking for the measure of this arc length here. That's where x is. Versus looking for where the angle is here. Okay? So I'll show you both examples. So for this one, you know that 60 degrees is going to equal 55 plus x divided by 2. So the first thing you're going to do is multiply this side by 2 because it's division, so the inverse is times 2. And you get 120 equals 55 plus x. To figure out what x is, you subtract 55 from both sides. That cancels out, and you get x equals 120 minus 55 is 65 degrees. So this arc right here is 65 degrees. Okay. Now, notice the difference. Over here, I am looking for an angle measure, not the arc. So in this case, x is going to equal 75 plus 123. And this whole thing is getting divided by 2. So for this one, you add these, divide by 2. If you're going to put it in your calculator, make sure you use parentheses or hit enter. And then you should get x equals 99 degrees. So be careful what you're looking for. For both of these, you are looking for the angle measure. So for both of these, you're going to follow this example here. Right. Now you'll notice number 27 and 28 look a little bit different. You've got the vertex outside of the circle. So let's go ahead and take a look at what those notes look like back here. Okay. So for the last few problems, numbers 27 through 38. You'll notice we've got several different situations, and so I'm going to go through all these notes with you because they all kind of use a similar formula, okay? First of all, if the intersection happened inside, you're going to plus. And I kind of see this crisscross as kind of a plus sign. So note you're going to plus the angles for that. When the angle is outside the circle, well, then you're going to subtract. And we've got two arcs. We've got a major arc and a minor arc. Well, you always want to subtract the major arc. So that's going to be the bigger arc. And the minor arc. So the minor gets subtracted from the major arc. And then you divide by 2. So in this case, what I would do is 240, and you can see the problem here. The only thing I like to do is instead of multiplying it by 1/2, I like to write it like this, dividing by 2. It's the same thing. To me, it just looks less intimidating. You know how we feel about fractions. So if you just divide by 2, it makes it a little bit easier. So that's one way this picture can look. There are 2 other ways this picture can look, and you'll solve it the same way. Another one is here. Again, you'll notice the angle is on the outside. This is your major. This is your minor. So again, you're going to do 100 minus 30 and divide by 2. And instead of writing it like this, I like to put the divide by 2 here. Instead of writing it like this, I like to put the divide by 2 here, but you can do it either way. Same situation. Start with the larger arc, subtract out the smaller arc. And the third and final way you'll see this kind of problem is like this, where you have a tangent and a secant. Again, my angle is on the outside of the circle, so I'm going to do it the same way. This is my major arc, because it's the bigger one, so I'm going to subtract 164 minus 70, and then instead of writing like this, I'm going to divide by 2. Okay, so those are 3 pictures, but when the arc is on the outside of the circle, when the angle is on the outside of the circle, you're going to subtract the arcs. And you always subtract the smaller from the larger. So let's look at some example problems back on page 10, starting with number 27. Hopefully. Okay, so here we go. And again, you're going to solve all the problems the same way. What's interesting about 27 is you can just be given one arc, and you can figure out the major arc by just taking 360 minus 125. And that gives you 235. So my major arc is 235. So my formula, this is what I'm finding, x right here. So x equals the big arc, 235, minus the little arc, 125. This whole thing's getting divided by 2. And when you figure that out, x equals 55. You're going to use this same formula for the rest of the page, all the way through to number 38. If you have any questions, please let me know.